Hi everyone, this video is basic introduction to inverse trigonometric functions. Let's have a look at first question. Do the following functions have inverse functions? Why? So the first one is y equal to sine x, and we are familiar with these graphs now. Let's use a horizontal line test to see whether there's inverse functions or not. Now when I draw the horizontal line, there are many intersection points. What that means is you have many inputs that will produce the same output. So you have many inputs with one output. So when we actually want to reverse back, it's really hard to go back which one it is. And same as cosine function as well. When I draw the horizontal line test, many intersection points, again, means the same thing. Many inputs for the same output. So it actually failed the horizontal line test. And this is the same for the tangent function as well. As you can see, there are many intersection points when you actually draw the horizontal line. Now, let's assume the inverse functions actually exist. So I have drawn the graphs here. You can see there's a pink curves on the graphs below. They actually represent the inverse function of each individual function above. Now, there's a problem here. If we want to call them a function, then the function itself must pass the vertical line test. So if I draw the vertical line on the pink curve, you realize it has many intersection points. So you have one input, but it produces many outputs. If that's the case, we say that it cannot be defined as function. So the same thing actually for the cosine inverse as well as the tangent inverse. You can see that when I draw the vertical line, all of the pink curves has many intersection points. How can we make these functions invertible? Let's have a look at the first one. We can actually restrict the domain. I'm going to pick one part of the curve, which is from this point to this point, and that is negative pi on 2 for x, and on the right hand side will be pi on 2. So I restrict the domain from negative pi on 2 to pi on 2. What that means is my range is now between negative 1 and 1. When we restrict the domain, I only have this part of the curve. When I draw the horizontal line, it actually has one intersection point. So therefore, it actually passed the horizontal line test. Therefore, it became invertible. Now let's have a look at cosine function. For the cosine function, I'm going to choose a part of the curve again, which is from here to here. I'm going to use this part of the curve. So my domain is restricted to 0 to pi. Therefore, the range is between 1 and negative 1. For the tangent function, I'm going to choose the curve that is going through the origin. And we know the tangent function has many vertical asymptotes. What that means is the curve never touches those asymptotes. So because I'm choosing this one here, my domain is between pi on 2 and negative pi on 2, but never touches those asymptotes, so therefore there's no equal sign. And the y value can be any real numbers because the curve keeps going up and keeps going down. So the range can be any real numbers. So based on these curves that we have for the sine, cosine, and tangent graphs, we're going to actually draw the inverse functions graphs based on the symmetry with respect to y equal to x. So these are the graphs of the inverse functions. So what we're going to look at now is the domain and the range of the inverse functions. So for the domain of the inverse functions, you realize that x is between 1 and negative 1 inclusive, and the range, let's say y, let's say the whole thing is equal to y is between pi on 2 and negative pi on 2. For y equal to cosine inverse, we have domain between 1 and negative 1 as well, inclusive, and the range is between 0 and pi. And for tangent graph, the domain, you can see that it keeps going to the right and going to the left, all right, but never touches two horizontal dotted lines there. So that means x can be any real numbers, and the range is between pi on 2 and negative pi on 2, but because it never touches those two horizontal lines, so there's no equal sign. Let's have a look at the notation for the inverse functions. You already seen some notations above, so that's actually one of them. So for the inverse of sine function, we can say y equal to sine inverse of x, or we also can say y equals to arc sine x. They actually refers to the exact same thing. They both represent the inverse of the sine function. So that will be the same for the inverse of the cosine function. You can use that -1 for the inverse, or you can say it is arc cos x, and same as tangent, so it's tangent -1, or y equals to arc tan. So I don't prefer to say -1. I always say sine inverse, so that it's clear with language, so I know what I'm talking about. Now let's quickly have a look at the graphs, the relationship between the graphs of y equals sine x and the sine inverse, same as cos and the tangent as well. As you can see, the blue curve represents the inverse function, and you realize that all of them are actually symmetrical with respect to y equal to x, that dotted line that you can see. Now, one special note. Please remember, sine inverse does not equal to 1 over sine x. That -1 means inverse. It's not reciprocal.